Good afternoon, everybody, or good morning, or good evening, good night, wherever in the world you are. My name is Martin Dürst. In Japanese, just call me Martin. And I'm going to talk about regular expressions, amazing and dangerous. So the topic today is regular expressions. Regular expressions can be amazingly convenient, but they can also be extremely dangerous. And my talk is going to focus more on the last part, on the dangerous part, than on the amazing part. Okay, what's the motivation for this talk? The motivation is this feature 17837, proposal by Sam Saffron to add support for regular expression timeouts. The question is how to detect or prevent dangerous regular expressions. And why are they dangerous? Well, they can be very slow on some inputs. It's not that the regular expression and as such is slow, but some of them can get extremely slow on some inputs. And currently there are two ideas for this. One is, as the title of the proposal says, a timeout, a special timeout for regular expressions. And the other one is a backtrack limit, which means that we count how many times in a regular expression it has to go back up, and then we limit that number. Okay, and this is what I'm going to talk in this talk. Well, the background to this is what's called regular expression denial of service. This is an active research topic, and it was particularly treated in James Davis's PhD thesis, which is 400, just trying to show it here, 450 pages. And I read all of them so that you don't have to read them. And I hope I can tell you some of the stuff that is described in there. And some of the stuff also that I have done myself based on this thesis. Here are some conventions. We are going with conventions over configurations, but I'm just moving on. And probably if you're a Ruby programmer, you have all used regular expressions. Well, when you did that, did you have any problems? What kind of problems? And who has experience, or at least knew, that regular expressions can be very slow? Well, for example, if you take an introductory, have to move that around so that you see it, an introductory book about regular expressions, I didn't find any mention of the fact that if you make a mistake in a regular expression or so, if you don't think it through carefully, it can get very slow. Of course, Jeffrey Friedel's book, the famous book about regular expressions, that one talks about speed. Anyway, so a little bit of information about myself. I'm from Switzerland, but unfortunately, I'm not in sunny Switzerland, as the background might suggest maybe. I'm actually now in rainy Tokyo. And okay. And my main contributions to Ruby are in the following areas. One of the next things will be to update Ruby to Unicode 14, which should happen in a month or so. Okay, so why are regular expressions amazing? Well, regular expressions are a domain-specific language, a DSL, well suited for stream processing. For Ruby, we are often talking about domain-specific languages in Ruby itself with classes, with methods, and so on. But domain-specific regular expressions are very, very specialized language with very different syntax. And for Ruby, this is quite important. I have on several cases when I proposed some new functionality for internationalization in Ruby, for example, Mats often said, well, you can actually do that with a regular expression, so why do we need a separate method? Ruby is one of the languages where regular expressions are used very frequently. And regular expressions are amazing because they have a compact and intuitive syntax. If you write Perl or Python or Pascal, it just means what it says. Yeah, it will match Perl or Python or Pascal and nothing else. Yeah, and so the syntax is very compact and very intuitive. Yeah, there's few additional characters, and the or character sign is very clear, and so on. But unfortunately, that's only the case for simple cases. Yeah. And also the basic semantics are very simple. It's a sequence alternative, as we just saw, this or this, and then also repetition. Now let's look at some examples of amazing. Yeah. First, we have the usual stuff. Yeah. Simple string matching, extraction of pieces from longer strings, replacement of pieces of string by other pieces, splitting up strings in various parts, into various parts. Yeah, that's the bread and butter. That's a big part of what Ruby is used for, and that's where regular expressions are at their best. Then another example, this is a real example. This is an example in production in Ruby. Every one of you can use that immediately in IRB or in Ruby. This is the efficient pure Ruby Unicode normalization. And it uses some regular expressions, and it works quite well, although it's really a very strange way of using regular expressions. Then the next example, there's also an example that I did, but that was years ago. That's why I have to apologize. That was in Perl, an implementation of the Unicode bidirectional algorithm in a few lines of Perl, and you could do the same in Ruby. And then here we have a Surreal example. Find the smallest prime factor of a number that is greater than 1. I mean, the smallest prime factor is always 1. Well, actually, no. If 1 is not the prime and 1 is not the prime, then the smallest prime factor must be bigger. Okay. So how do we do that? We take the string 1 character. We create a string of the length of the number that we want. And then we match it with this regular expression. And the match will result in the part here, show up as $1, and its length will just be the smallest prime factor. Yeah, 63 is 7 times 9, so 7 is the smallest prime factor. Okay, let's go to the next slide. Let's look at this in more detail. How does it work? First of all, the caret and the dollar make sure that we match the whole string and not only part of it. Yeah, or at least the whole line, but in this case, the line and the string are the same. Then the 1+ here means one or more once. Then 1 plus means 2 or more ones, yeah? And if the question mark added, it means 2 or more ones, lazy. Prefer as few as possible, yeah? And then the parentheses say, remember what you matched and make this available as \1 inside the regular expression and as $1 outside the regular expression. And then the \1 star says, well, whatever you remembered, 0 or more times, yeah? And so what we end up, for example, if we use that with the number 9, then on the first try, we start with 2 ones, and then we have 2 and 2 and 2, and only 1 left, so we fail. On the second try, then we go with 3, and then 3 and 3, and we succeed because we just exactly eat up the whole string, and we succeed and get the result of 3, which is correct because 9 is 3 times 3. Okay, and this goes very fast, yeah? But this can get slow, yeah? If you take a number like this, 11,000 and something, it's still quite fast. If we take 99,000 and something, and these are all prime numbers, then it can take 2.7 seconds. That was on my machine. On your machine, of course, the mileage may vary. And if you go higher, then it gets slower very quickly. And if we do a general kind of estimate, then this 99,000 is about half of this 190 something thousand. And the time here is about 4 times, so double and 4 times. So this means that this is about quadratic, yeah. And this is a very silly, surreal example that regular expressions are dangerous and they can get dangerously slow. Okay, so there is a famous quote that I didn't want to miss. It says, some people, when confronted with a problem, think, I know I'll use regular expressions. Now they have 2 problems. Well, I hope that my talk will help you a little bit to not have 2 problems, but to actually solve your problem. There's also some background on this quote. You can look at it if you want. A lot of the text in this talk is linked. So once you have an access to the slides, you can follow the links. And one reason why I wanted to show this quote, one reason is that it's really very famous for regular expressions and for the problems we're speaking about. But the other is that I have never met Jamie Zawinski, but I actually, by chance, have authored an RFC with him. Anyway, okay, so why are regular expressions dangerous? First, they are too well suited for string processing. At some point, you start to like the hammer of regular expressions, and more things that are not nails start to look like nails, and you start to work with your hammer on these things and use regular expressions where maybe you shouldn't. I mean, the prime number example was definitely an example, but there are less obvious examples. Next problem is compact syntax and complex syntax. For example, the plus and the question mark each have a rather easy meaning, but if you put them together, they mean something different. Yeah? And that happens with many more of these characters. Yeah? Also, the semantics are complex. Yeah? You have something like back references, something like look ahead and look back and look around, and I don't know. And every once in a while, some language that has regular expressions comes up with a new idea, and then the other languages say v2, 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 and it gets more confusing. Yeah. But there's a lot of me too in this regular expression implementation business, but there are also many variants. Yeah. And there is, as we already saw, the unpredictable time behavior. Why is there an unpredictable time behavior? Yeah. Simple regular expressions can be processed extremely efficiently. There are implementations that do that, but they're severely limited in what regular expressions they can accept. Yeah. And if you want extended full functionality, you need a more general algorithm. And that algorithm does backtracking. It tries every possibility in a well-defined order. It's like going into a maze, and whenever you hit a bifurcation or several choices, you always first you choose left, and then next and next and next and next, and you go as far as you can until you hit the dead end, and then you go back and choose the next choice. Yeah. And optimizations are possible, but they vary by implementation. And so some optimizations work for some regular expressions and not for others. Yeah. Regular expressions come in all kinds of forms and shapes. Yeah. And let's just show you an example. You can show that example, look at it at home. In IRB, if you type this, a string .Unicode normalize NFC, and then you print out this regular expression, then you see it starts with a slash, so it is actually a regular expression. And then depending on what fonts you have available, you'll see more or less of all this stuff here. And it's quite long, and it's long and flat. It's long and flat. Whereas other regular expressions can go very deep for a very long string. Yeah, this one is for very short strings. Okay, so regular expression denials of service. I already mentioned it. There have been some famous incidents, and the question in the issue that I mentioned originally is, how can we avoid it when using Ruby and in Ruby itself? And for that, we need real data. And so what I did is take a large collection of regular expressions, extract the regular expressions relevant to Ruby, find slow regular expressions, and input the input where these regular expressions will be slow, and then examine the exact behavior with Ruby and see what would work best to stop slow regular expressions. Okay, the data I took from this is all from James Davis, different papers that he put together in his PhD thesis. This is where I got the data from. And then I used a regular expression, a vulnerable regular expression detector by James Davis, which actually uses 4 different vulnerability detectors written by other people, which use different strategies. For example, one of these detectors uses rewriting of expressions. It tries to simplify the expressions and then find patterns that it knows might be vulnerable. Another one uses actual examples to do some kind of fuzzing-like stuff, and so on. The problem is that it's not easy to just take a regular expression and say, this must be slow, or this will always be fast, or so. And for this evaluation, I used Docker that was a very nice experience with Docker, having 30 or so processes together. This was the hardware I used, sometimes overnight, running tens of jobs in parallel on 2 different machines. Okay, now some of the regular expressions that I found, here's an example. This is an expression that was diagnosed as slow. Let's look at the details. Here we can display the structure. This is something you should occasionally do with this X at the end. You can show it with line breaks and spaces. And you can then see at least a little bit. We have a star here for this whole group here. And then we have a star here again, which means that this can get dangerous. Yeah. And then we have an attack vector. The attack vector says what kind of string will make this expression slow. And it consists of a prefix, then something called pump. The pump is used multiple times, maybe 10 times, maybe 100 times, maybe 10,000 times. And then we have the suffix. Often the suffix is nothing, but sometimes it's something. And then the timing here, you see, even just with a very short version, with a few pumps, it quickly times out. It's exponential. And the reason for that is these nested quantifiers. Okay, here are some more results that I got. Well, overall, I started with data on 500,000 unique regular expressions from 8 different languages that I downloaded. I extracted just the ones that were found in RubyGems. This gives 150,000. And then of these, 234 regular expressions were dangerous or vulnerable. Yeah. And the number of pumps to make them timeout, most of them were very low. Yeah. Some of them were higher, like 10,000 or so. Also, most of them failed. Yeah, it's easier to construct something that is slow and fails because it has to, well, it tries all kinds of things and never finds something, so it has to work on them. Okay, so how can we improve Ruby? Well, one proposal is to introduce the timeout. The advantage would be that that's very directly clear what it means to the user. The problem is that Ruby level timeouts don't always work. Actually, there's some regular expressions you can run, and they run for hundreds of seconds, and then just the timeout doesn't work. Yeah. And I dealt that by using external processes and then just go and kill them. Also, the implementation may be tricky or slow things down. The other alternative is backtrack limit. Nobu Nakada already did an initial implementation. I found that it has some problems. For example, there's no way to find out how many backtracks it took when there's a failed match. I tried to fix that, but didn't come up with a complete fix. So what I ended up was I just used the limit and said, and did binary search with the limit to find out exactly how many backtracks regular expression with some input would need. But there's still a problem there because some slow matches don't show any backtracks. So we're not either not counting it correctly or there's something else that we have to control. And my opinion here is very clearly fix. It would be good, it would make Ruby a better citizens if we could fix this redos problem. And we have basic solutions available, but we need more work. With all the data I have, we can actually evaluate different solutions quite well. Okay, I'll skip this and go to the recommendations. These are recommendations for everybody. First, think about where regular expressions are really the best tool for the job. There are many places, but there's some places where they aren't. Yeah. Then use the X options to make regular expression structure visible. Write tests for your regular expressions. One problem is the test coverage, also debugging tools. Most tools, they just treat regular expressions as a big lump and are not able to look inside regular expressions. Then check for potential slow regular expressions. You can do that using various online tools. And also restrict the length of input strings. There's some regular expressions that blow up when you feed them 10,000 characters, but the usual input would maybe just have 10 characters. So if you set the limit at 100 and reject longer ones, then you're on the safe side. And also, that's very important, avoid regular expressions as user input from end users, because otherwise that's going to expose you to such kinds of attacks. Okay, so there's some acknowledgements. And now maybe we have time for questions. If there are any questions. No, if there are no questions, then I thank everybody for listening to this talk. And I hope we can implement these measures so that we don't get regular expression denial of service attacks. Thank you.